question doesn't state a standard deviation.
True. Um,
So for question one, part A, like I was confused what equation to use.
so here you're gonna use a t-test, right?
Okay.
The test statistics is a t value because here you have like a set of random number and you want to determine if statistically they have a mean of mu equals 0.338.
Right.
So basically, this is called a one sample t-test. And
Mm-hmm.
again, we have two sample t-test, which I mean, in the Darwin's experiment, you should have discussed about two sample t-test. But the one
Mm-hmm.
sample t-test is basically you have a set of numbers, and then you
Mm-hmm.
want to conclude what is those numbers statistical average, statistical mean, right? So first, those
Right.
numbers have a mathematical mean, and it's very easy to calculate. You just sum them up and divide it by how many numbers you have.
Mm-hmm.
That is the mathematical mean. And it's a
Correct.
very precise and specific number.
Mm-hmm.
However, in statistics, we are kind of um, broader our interval. Uh, we say, okay, those numbers they may be chosen from a broader population, right? From like I would say 10,000 numbers, I chose 15 numbers from them, and the population have a mean of, for example, 0.338. Um, but because I'm randomly choosing 15 numbers from that population, so I cannot guarantee that the mathematical mean of our 15 observations um, lies exactly at 0.338. You can have some, um, you can be a little bit greater than 0.338, you can be a little bit smaller than that, but it cannot be like way larger or way smaller than your population mean. And how to determine that? We use the t-distribution, we use the t-test. So basically, you first calculate its mathematical mean, which is a very precise number, and then you minus your null hypothesis, which is here mu equals 0.338, and then you divide it by standard error. So the denominator should be standard error, which is, I think it's standard deviation divided by square root of n, where n is how many numbers you have observed. That is a t-test.
Correct. But how with the equation it gives me the sparging rate, um, the mu and the um, sample number, but it does not necessarily give me the standard deviation. So I'm not sure how to calculate that.
Mm, so,
Maybe I could have read it wrong though.
so basically, you have a set of number. You can calculate
Hmm.
everything. You can calculate standard deviation. You can calculate the mean. And
Okay.
basically, standard deviation is how much fluctuation your set of data set is compared with its
Mhm.
mean, right? If I have 10 number, which like I have 10 numbers which are all threes, then my
Mhm.
mean should be 3 and standard deviation should be 0 because there's no fluctuation at all. Um, and the formula is you, you choose your first number and then you minus the mean and then you square it, right? And then you sum all the numbers up and divide it by n if that's our population, divided by n minus 1 if that's the sample. Here is the sample, so divided by n minus 1. Um, but again, you can just Google like statistical calculator or something, and then
Oh, and just calculate it that way.
yeah, you just click on I would say the first two links, and then you input
Hmm.
all those numbers. but make sure you are calculating the standard deviation of the sample, right? Because for the sample, it's divided by n minus 1, whereas for population, it's divided by n, right? The difference between a
Mm-hmm.
sample and population is, those bubble velocity, they're just several observations. It's representative, but it's not the whole story. So that's a sample of 15 observations.
Correct. Do you think that we'll get a question like this on our final, possibly, where we will have to calculate the standard deviation by hand based on like a problem like this, or is it not likely?
I would say not likely.
Mm-hmm.
But again, I would say not likely. But
Mm-hmm.
in some graphical calculator, actually, it has similar function as you Google a statistical calculator. Like graphical calculator, basically, there's some, I would say, algorithm, something, and you just input all those numbers and it gives you a standard deviation. But you should be familiar with the formula of how to calculate the standard deviation and the the definition of standard deviation.
Okay. And then I have one more question. Question three, part B asks, what is the reference distribution? What exactly is the reference distribution? I'm kind of confused with that.
Okay, so I'll go over the whole question actually, because I think it's kind of difficult. Uh, so basically, this is a z-score test, right?
Mm-hmm.
You're gonna refer to z distribution. Like the logic here is, so basically, this question is just what I said. It should be like a two sample t-test, right? You have one observation, which is cross-fertilized crop something, and another one is self-fertilized. And you want to
Mm-hmm.
compare if those two groups are different or not, right? Which technology should we use? We use cross-fertilization or self-fertilization based on different productions, right? You're gonna choose
Correct.
better technology. Um, the best way is just do a two sample t-test and to see which one has a higher statistical mean, right? But here the sign test is kind of more convenient, but sometimes not very accurate. But it's very convenient, very simple. The logic is you just find the difference of those two groups. You find the difference between the cross-fertilized and the self-fertilized. Fertilized, and basically you generate a new set of data, and some of the numbers are positive, some are negative, right? If I use a cross minus self-fertilized, then the positive number means in that specific observation, the cross-fertilization is better than self-fertilization. And I
Mm-hmm.
have 15 observations in total. So basically, the intuition is, for example, I have 8 positive number and 7
Mm-hmm.
negative number. Then I would say maybe those two technologies are similar because by applying those two technologies, um, I find 8 observations where cross-fertilization is better and 7 which cross-fertilization are not that good. But
Mm-hmm.
basically it's similar, right? That's the intuition of the sign test, where I only care about the sign, I don't care about the magnitude. That's a huge problem, where if you use a two sample t-test, you're gonna care about both sign and magnitude, because we know magnitude is important, right?
Mm-hmm.
If in several observations, the cross-fertilization is way better than self-fertilization, even though it's an 8-7 sign test, I'll still use cross-fertilization because in some of the observation is way higher. Um, so this should be a binomial distribution if you if you notice it, because
Mm-hmm.
basically I only have two results, positive or negative. And under my null hypothesis, I assume those two technology is the same. Statistically, they are the same. So the probability of getting a positive number should be 50% under my null hypothesis. Similarly, the probability of getting a negative sign is also 50%. And then based on my observation, right, you should actually difference those two groups. And you find a new data set, maybe you find 10 positive and 5 negative, right? It's like you're tossing a coin, you find 10 heads and 5 tails. There is a
Mm-hmm.
probability associated with that. And by the way, that's binomial distribution. So here uh, you're facing a hypothesis test, right? If you get 10 heads and 5 tails, what is the probability that the chance of getting a head and tails are even, are 50-50? The probability
Mm-hmm.
is actually very small. And what you're gonna do is you do a z-score test. The binomial distribution, the standard deviation is NPQ, right? Under null hypothesis, it's 15 times 50% times 50%. And the square root of that is your standard deviation. And you use your yeah, that's your standard deviation, but it's not. We don't even use standard deviation in this case because you can directly calculate the probability. It's traced back to like the first several class you have,
Mm-hmm.
where just like you toss 15 coins, what is the probability that you get more than 10 heads, right? It's a very standard binomial distribution question, but here it's like first you have a null hypothesis, you assume those two technology are the same, and then you use the binomial distribution to calculate the probability, which is the p-value. And if
Right.
that's lower than 5%, I would say, then that means your null hypothesis is wrong statistically,
Okay.
because the chance of your null hypothesis getting right is less than 5%.
Mm-hmm.
So that means those two technologies are not the same.
Okay. I understand it now. Thank you so much.
Sure.
I will join back if I have any more questions, but thank you so much.
Sure. Never mind. Have a good night.
Bye bye.
Bye.